To our YouTube live here at the European Spaceport in French Guiana, and there's our rocket on the pad, Vega-C, getting ready to transport 2 very important missions and 5 satellites to space. CO3D, which is going to map the surface of the world in 3D, and Microcarb to measure CO2 and help us understand our planet and how it breathes, tucked up there inside the fairing. We're 15 kilometres from that pad here in the Mission Control Centre, and joining me in the commentary box overlooking the fishbowl there is Loïc Leroy, who is a systems manager from Arianespace for Vega-C. Loïc, it's great to have you with us.
Hello, Katie. Hello, everyone. It's really nice to be here tonight with you.
Yeah, really good to have you with us and your expertise. Let's go inside the fishbowl now, inside the control room, to find out how things are going. The head of the flight desk is David Cavallolis, the CEO of Arianespace. David, thank you so much for coming to chat with us. How are things progressing in the countdown?
Well, Katie, this is a pleasure to be with you tonight. So now the rocket Vega-C is standing on its launch pad. The mobile gantry that protected the rocket has been rolled back. All the parameters are green. The weather is okay, so we should be able to launch the mission in now a little bit less than 20 minutes.
Well, that's all good to hear. And tell us a little bit more about our passengers.
Yeah, for sure. Tonight we'll have a very special mission because, in fact, with one rocket we'll deliver 2 missions for 2 clients, the CNES and Airbus. So the first mission is called CO3D. It's a constellation of 4 optical satellites that will map the whole globe, that will map our planet in 3 dimensions, both for commercial and for public purposes. The second mission is called Microcarb. So Microcarb is a satellite that will identify the sources and the sinks of carbon dioxide everywhere around the world, and it will be a very powerful tool to fight against climate change.
Very important indeed. And what does a complex mission like this tell us about Arianespace's ability to deliver for its customers?
Well, it's simple. We are proud. We are proud to deliver such a complex mission. We'll have to inject those 5 satellites into different orbits. But beyond the technical complexity, I'm proud to deliver a mission that will contribute to provide services to our citizens, whether we talk about security or about climate change. So very important day for us today.
Well, best of luck, and thank you very much indeed, David, for coming to chat with us. David Cavallolis. So, Vega-C on the pad, waiting to lift off in 15 minutes and 49 seconds. What's going to happen after that, Loïc?
Well, first of all, we will see the ignition of the first stage of the Vega-C rocket, the P120. It will allow us to clear off the coast from French Guiana and head over the north. The burn of the P120 will last about 2 minutes and 20 seconds. After that, we will separate it, and we will start to ignite the second stage, which is the Z40, for about 2 minutes again, and we will head north, raise the altitude of the launcher. Once it's consumed, the Z40 will separate again to get rid of the extra mass that we don't need anymore. And then the third stage, the Z9, will take the floor on the launch and once again raise the launcher into the atmosphere. An important milestone we see on the screen is the fairing jettison, approximately 5 seconds after Z9 ignition. And then we'll have the satellite see the outer environment for the first time. The last stage, the Avon Plus, will then ignite for the first time during the mission over Canada, and after that it will shut down for what we call the ballistic phase, so we will not need the thrust anymore, and once we will be back on the other side of the Earth, we will be above Australia, we will be acquired by the station of Noonorshire, and we will ignite again the Avon Plus upper stage for the separation of CO3D. After that we will continue our mission to the Microcarb orbit. So here you see the CO3D separation animation. Then the third boost of the Avon Plus, going over Antarctica, coming back over South America, a 4th boost for a precise injection of a Microcarb, and then over the Bermuda station we will be able, in about 1 hour and 41 minutes after liftoff, to separate Microcarb on its orbit. At the end of the mission, we'll have a 5th boost to re-enter the atmosphere for the launcher.
And as we saw there, the first mission to be delivered will be the 4 CO3D satellites, which are going to create that digital model of our planet in 3D.
Exactly, with many applications and important ones, both for civilian use and for armed forces as well. Also giving some 2D imaging for government and commercial clients.
Indeed, they're packed with innovations like AI for detecting airplanes or ships, laser communications, night vision even, so they can even show us streets and car parks in low light. So let's take a closer look now at our constellation CO3D. various people watching the launch over in the Cité de l'Espace. Here they are in Toulouse, the space city. The teams there who've been involved in building our missions and making our missions happen and making them a reality. Big shout out to you guys.
Yeah, such a great crowd there in Toulouse. It's very late over there in France, and you can see the joy. There are, I guess, all the people involved in the projects for CO3D and microcarbs.
Oh, fantastic. I love the Steins. And over in Colleferro, these are the teams in Italy, in Rome. These are the teams for Avio who build the rocket.
Yes, exactly. People from Avio who are the prime contractor for the launcher, and they are in Colleferro in Europe, in Italy, for supporting the launch in case their knowledge is needed for any kind of event for this liftoff scheduled in a few minutes.
Always good to have as many people on the job as possible. And we also have another team here in the Guiana Space Centre, the Launch Control Centre. Terribly important at the moment. They're really concentrating. Their job is very much about the rocket and the pad.
They're basically the people who are making it happen. So they are setting all the parameters and all the preparation for the launch pad and launch range and the launcher, of course, to prepare for the liftoff. So very focused and very concentrated right now to make it happen.
Coming up now to the beginning of the next important thing, which is the automated sequence, or the synchronized sequence, as it's often known
À
as
tous de
well.
DDO. Attention pour la séquence finale lanceur.
Xavier Nero there, the range operations manager, getting ready to announce the last 4 minutes in the countdown.
Top. H0 moins 4 minutes.
There we have it. The last 4 minutes, the beginning of the synchronized sequence has been announced.
Yes, it's an important part of the chronology because the launcher is now becoming autonomous. It's making a lot of calculation and a lot of preparation for the liftoff, and completely in an autonomous way. So we are on the last phase of the countdown right now.
Indeed, the last phase of the final countdown. But the job of preparing the rocket and the spacecraft here at the spaceport to bring us to this last phase of the final countdown started some 6 weeks ago, if not more. We call the process the launch campaign, and our cameras have been there. What's been happening?
So first of all, we have brought to French Guiana the P120 stage. You can see it on the screen. The first booster, the first part of the rocket, the main one. And then the second stage, the Zephyr 40, was brought to the launch pad, and you see the mobile gantry, which is the assembly building, basically. The stage was put on top of the P120, and then the third stage as well, the Z9, was brought to the launch pad and assembled on top of the launcher. So step by step, we see the Vega-C rocket getting to life, and then the last stage, the Avon Plus, is brought also and assembled on the launcher. In parallel, the satellites have arrived in French Guiana by plane in Cayenne, and they were transported to the Space Centre here in Kourou, and unpacked, of course, and prepared for any kind of test before the integration on the launcher. You can see here the teams working to prepare the satellites. For Microcarb as well, it arrived in Cayenne about 1 month ago and was transported to the Space Centre, prepared and tested for making sure it is in perfect conditions and perfect preparation for the assembly on the launcher. Here you can see these people in funny suits. They are like cosmonauts, but they're actually protecting themselves from chemical propellants. And you can see the microcarbs type getting ready. Once they are all assembled on the dispenser, they were put inside the fairing, so the nose of the rocket. It's the last time we see them actually before they go to space. And then the fairing, as you see, was transported to the launch pad, hoisted on top of the launcher very gently before the final countdown.
And here we are today, 1 minute and 30 seconds to launch. All eyes glued to the data on the screen at this point, hardly blinking. It's a very intense moment, this, isn't it?
Yeah, it's a moment of high concentration, and I can feel the
À
tension
tous de
here.
DDO. Attention pour moins 1 minute. Top. H0 moins 1 minute.
We are 1 minute to launch. We are live at the European Spaceport in French Guiana, getting ready now for the launch of CO3D and Microcarb on board Vega flight number 27. Good luck, everyone.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage P120 et décollage. La propulsion est nominale. La propulsion est nominale, le pilotage est calme. Acquisition de la télémesure par la station de Saint-Jean du Maroni. La propulsion est nominale, la trajectoire est nominale. La trajectoire est nominale.
Vega-C,
Le pilotage est calme.
Passengers CO3D and Microcarb shooting across the equatorial skies here at the Guiana Space Centre, blazing a trail into
trajectoire est nominale.
space. The range operations manager is telling us that everything is going normally. And we have some stunning images here, Louis.
Yes, we're lucky because the sky is quite clear tonight, so we are able to see the show for a bit longer than sometimes we are a bit frustrated when the clouds are on, but tonight is nice.
La trajectoire est nominale, le pilotage est calme.
The trajectory is normal, the piloted
Début de la queue de poussée du P120.
Is calm. We are burning the P120.
Yes, right now we are with a large thrust and the satellites probably feel it, but they are safe inside the fairing right now and we are blazing across the atmosphere.
La trajectoire est nominale.
If we're lucky, we might actually see the... There we go. We see there the
séparation du P120.
And separation of the P120
Allumage
first
Z40.
stage, confirmed there by the range operations manager, who has also confirmed ignition of the next stage.
Yes, the Z40, the Z40 for Zefiro 40. Zefiro is an Italian name for zephyr in French. It's a type of wind, so a very poetic name for a booster, which is quite strong and powerful.
Pilotage est calme.
He's telling us that everything's going well, everything's going according to plan. I'm amazed we're still seeing these beautiful images. 3 minutes and over 3 minutes into the launch. Very clear there. We're looking at the engine there of the Z40 second stage, because of course we're very much in the propulsion phase right now, getting us away from the gravity of the Earth.
Exactly.
At the top
Propulsion nominale.
The rocket, we saw it earlier, we call it the fairing. That's where the satellites are presently housed.
Le pilotage est calme.
He's telling us that everything's going well. Fairing, of course, it's an external structure used for lots of different vehicles, for high-performance cars, motorcycles, boats, that sort of thing. It's to increase streamlining. He's telling us the trajectory is normal. petrol heads and bikers amongst you will know about fairings, and in this case, of course, it's protecting
Début de
our
la queue de
rockets.
poussée du Z40.
It's an important structure to protect the satellites because, as you could feel maybe here in French Guiana, but also on the live broadcast, that the sound of the liftoff is absolutely
Le
huge.
pilotage est calme.
It would damage the satellites if they were not protected by this fairing structure. And also, of course, during the atmospheric flight, we need to avoid any friction from the air. So we will remove the fairing once we have reached a less dense part of the atmosphere and that the satellites are fine.
Séparation du Z40.
Confirmation of separation of the Z40.
Allumage du Z9. La propulsion est nominale.
Confirmation of
Séparation de la
switching
coiffe.
on of the Z9, the Z9, and separation of the fairing. All going well. We can see our satellites
Yes,
for the first time.
and they see the space for the first time. So, yes.
La propulsion est nominale. Le pilotage est calme.
Just explain to us what we're looking at here. We've got, so on the left-hand side, obviously you've got the what's left of the rocket. You've got a black structure, which is the adapter. But just talk us through, for anyone who's unfamiliar, what the satellites look like there.
So the
Trajectoire est
payload
nominale.
stack is composed. On the very right, you see the golden shape, which is microcarb.
Got a good
It's
view of it
gold
there.
because of the thermal insulation. It protects it from
La
solar
propulsion est
radiation,
nominale. Le
basically.
pilotage est calme.
And then underneath, you see this dark blue and black structures, which are the CO3D satellites. There are 4 of them, 4 optical satellites. And the white structure, which accommodates them, is a Clessidra Plus dispenser. It's a specific dispenser designed by Airbus Defence and Space in Madrid, Spain, under
propulsion
supervision of
nominale.
Avlo, as a prime contractor. It has been very specifically designed for this mission. It's a beautiful dispenser.
Of course, dispenser, meaning that it actually dispenses the satellites. So it's holding them now, and they're attached to it. But later on in
they will release it
La
very
trajectoire
smoothly
est nominale.
everything's going well. He's telling us. You can see on the top right-hand side there is our trajectory. That's the planned trajectory.
Le pilotage est calme. La propulsion est nominale.
The white cross is our actual position of the rockets, and then, of course, below that you've got our altitude. At the moment, we're 504 kilometers above our planet. We've travelled nearly 18,000 kilometers in terms of distance.
Début de
if you
queue
were
de
to
poussée du
draw
Z9.
a straight line along the Earth, and we are flying, 7.69 kilometers per second, everybody, per second, not per
quite a
hour.
ride.
Yes, quite a ride indeed.
Put your seatbelt on. Yeah.
Yes, indeed.
La
And we
trajectoire
have
est nominale. Le pilotage est calme.
a very nice view there of our satellites with the 4 CO3Ds looking rather like petals on a flower. Coming up to the next big moment there. On the left-hand side, you can see it, the separation of the Z9. That will be the Z9. That's how it looks in space. Our computer-generated
Séparation du
images.
Z9.
And we have confirmation there, showing us what's been planned for the mission.
Acquisition de la télémesure par la station de Bermude.
Oh, we've picked up the signal at the Bermuda tracking station now. It's a Caribbean island, very beautiful Caribbean island. I've been there. So Vega-C is checking in and saying hello to the
visibilité
teams
Saint-Jean.
there. And we've got out of range of the tracking station of Saint-Jean. So we're travelling north, as we said earlier.
Yes, exactly. We are traveling full north. So, as you said, we are now over the Caribbean, over the Bermudas Island. We're heading north towards Canada. And then we will go on the other side of the Earth, let's say, and we will have this ballistic phase I was talking earlier about with no propulsion. And once we reach, let's say, above Australia, we will acquire again the launcher telemetry, which is the data it is sending to us, and we will prepare for the separation of CO3D in visibility of New North Star station. So you can see the ignition of the AVOM on the screen.
And there's the
Fin d'acquisition de la télémesure par la station de Gallio.
So he's just
Premier
confirmed
allumage à zoom.
that we've gone out of range of the Gallio tracking station. That's the tracking station here at the Guiana Space Centre. And he has confirmed as well the ignition of the Avon Plus upper stage. which means that we've really now started the next phase of our journey, because the Avon Plus upper stage is a very, very clever piece of kit, isn't it? It's sort of a little bit like an orbital bus driver. It's going to deliver our satellites.
La trajectoire est nominale, le pilotage est calme.
To the right points.
Let's turn our attention now to the industrial teams who created our satellites. CO3D and Microcarb are a great example of European expertise in space, and I can tell you there is a lot of it. They're designed and built by two of Europe's aerospace giants.
Yes, two giants indeed. We have, first of all, Airbus Defence and Space today, which is leading all the industrial teams for CO3D. And
La propulsion est nominale, le pilotage est calme.
Responsible for AIT, what we call AIT, which is Assembly, Integration and Test of Microcarb in the UK, for the CNES for sure, but a very important role. And also Airbus Defence and Space providing the instrument, the most important instruments on the Microcarb. So both big giants of aerospace industry involved tonight, yes.
Yeah, and so obviously it's a big day for Airbus Defence and Space, and also for CNES, because they are indeed involved.
La propulsion est nominale, le pilotage est calme.
Everything's going normally, he's telling us. Gosh, these big space projects, they have thousands of people involved, don't they, often, and pulling together really to make it happen.
Yes, it's true that these projects involve many, many people in many diverse type of jobs, of course, engineering, but not only. And we're talking about sometimes 5 or 10 years of work on this project, so it's
La propulsion est nominale, le pilotage est calme.
To see the satellites be delivered on the right path and ready to do their missions.
No, indeed. And when you've been working for 10 years on a project, it must be really quite incredible. I mean, as you said, Microcarb actually was decided in 2015. So
Trajectoire est nominale.
And CO3D commissioned in 2019. But I wonder how they're feeling now, knowing their babies are on their way. It must be a good feeling after all those years.
For sure, and accomplishments. So many hours of work, of designing, analyzing, testing. So yes, these satellites are very precious babies, let's say.
Yeah.
And we make sure that they are safe in the rocket and they will travel safely and be well delivered on the right spot at the right time and in very good health conditions.
And CO3D has been quite a game changer, hasn't it, in more ways than one, and including the fact that
acquisition de la télémesure par la station de Gatineau.
CNES, I'll just interrupt just to say that we've picked up the signal there at the Gatineau tracking station in Canada. Yeah, new business plan.
Yes, indeed. Normally, Airbus supplies, let's say, a satellite system. Now, this time, they are supplying the whole service of imaging and data and so on. So,
la trajectoire est nominale.
The owner of the satellites. So that means that once the contract today is fulfilled, the satellites will be ready and available for other type of missions, imagery missions with other customers.
So we picked up the signal there at Gatineau, and of course the tracking stations send all the data
La propulsion est nominale, le pilotage est calme.
To the CVI, or the Quick Look Telemetry team. You can see them in the bottom right-hand side of your screen. They are a super important team of people
crucial
here.
team, because they are receiving all the data from the launcher, so propulsion module, trajectory, of course, and they are reporting to the operation.
La trajectoire est nominale.
So that's very important, and we can see tonight the team led by Armel Girard from Arianespace and supported by Justine Tenil. We have women on board tonight. It's important for us to mention that we have many women playing key roles tonight for this mission.
And they're up on a hill just outside the spaceport with...
La propulsion est nominale, le pilotage est calme.
Antennas and following, yes, everything, yeah.
Yeah, and as you say, yes, it's a lot of women working, actually, I've noticed, in women engineers and women in all sorts of fields in the space industry, which is great.
Yeah, for sure. We have a lot of women involved at different roles, from very top directors, managers to any kind of job, actually. And yes, we need women, spirit and intellect for our jobs, for sure. And we have a lot of jobs applications and diversity of jobs. So if you feel like joining the space industry, feel free to do it, because for sure we have a place for you.
La propulsion est nominale, le pilotage est
calme. Get your job
calme.
applications and your CVs ready. And it is actually, I mean, the space sector is a really interesting sector, isn't it? It's really rattling along, it's changing, it's evolving fast.
Yes, very much. In the late few years, we have been seeing a lot of new players in the industry. And as I said, that means we have a lot of jobs openings and a lot of new jobs also coming up.
La trajectoire est nominale.
So it's really interesting to see that there's a great variety of possibilities in terms of work and not only on engineering, I would say, but also many other type of jobs, contracts, legal,
Le pilotage est calme.
relationships.
Looking at the telemetry information coming in there, we're travelling now at just under 8 kilometres per second, which we're heading towards 28 kilometres per hour, which is pretty fast.
Pretty fast.
And our altitude, of course, coming up to now nearly 300 kilometres above our planet. And we're looking here at really interesting computer-generated images which are showing us what's been planned for our mission. We're getting ready now to shut down our engine on the Avon Plus upper stage, and
La propulsion est nominale, le pilotage est calme.
he's telling us that everything's going normally, so that's good news. And Avon Plus has a brain, doesn't it? That's how it knows what to do
Yes,
and when it has to do it.
Kind of a brain. Basically, it's called the onboard computer, the OBC. So it's the brain of the stage that constantly calculates the trajectory, the parameters and propulsion and so on, and make sure that we are on the right path and correcting it if needed, and making sure that we are aiming at the right spot to deliver the satellites.
Fin de visibilité, Bermude.
Of the engine.
La trajectoire est nominale, le pilotage est calme.
He's telling us that everything, the trajectory and piloting are calm and nominal. So this is the scheduled moment to start what we call the barbecue phase, which we will
Extinction
talk
de la
about.
VOOM.
And there we have confirmation that the upper stage has switched off its engine. So
we're
that's
entering
good.
the ballistic phase, so no propulsion needed anymore. And we will just use the gravity, let's say, to go all across the Earth.
So we're very much entering a coast phase now. As you say, we're travelling without our engine in our first ballistic phase, and we are moving around. Got a few manoeuvres going on here. What's happening?
Yes, right now, since we will be waiting, let's say, in a transition phase for quite a while, about 35 minutes, we are reorientating the launcher. Basically, we don't want to make the sun impact too much the satellites. We have optical devices that are very fragile on these satellites, so we want to avoid to have too much sun on them. And so you can see the launcher is turning and putting the rear of the launcher towards the sun. And we also see that there is another maneuver, which is a kind of actual spin, as you said, the barbecue.
Nice technical term there.
So we are kind of want to avoid also to overheat or over chill the satellites. So we average the temperature of them by rotating like this and making sure that step by step each of them is in the light, or on the contrary facing the void and the outer space.
So we are quite literally turning as if on a spit, on a rotisserie, and we've got a good view of it there. We're going to take a break, and we're going to come back to you in half an hour's time during this coast phase. So come and see us back here in half an hour. See you then. Beautiful images there of the Vega-C rocket lifting off from the pad here at the Guiana Space Centre. We are coming to you live. I have the pleasure of having Loïc Leroy in the commentary box with me, an expert, a rocket expert from Arianespace. Thanks for being with us, Loïc.
Hello everyone. Hello Kitty. Nice to be here again with you.
Yeah. So we are 49, nearly 50 minutes into the flight of CO3D and Microcarb on board a Vega-C rocket, flight number 27, the 27th Vega-C rocket. Tell us what's been happening so far.
Well, first of all, everything so far has been according to plan. Everything is really nice. So we have seen the liftoff, the beautiful images of the liftoff from the cool launch pad just before. And we had ignition and burn of the first 3 stages of the Vega-C rocket for about 9 minutes. And then the last stage, the upper stage, the AVU Plus, has taken the lead on the mission, and it has burned once until now. To raise the orbit of injection of CO3D. So now we are going to head over the New Norcia ground station, tracking station, where there are antennas tracking the launcher to get the signals from it. And once we have acquired this signal, we will be able to also see that the second ignition of the AVUM, for instance, and of course what we expect most of all is the separation of the 4 CO3 satellites.
And of course, you can see there on the right-hand side of our screen the trajectory, which is the planned trajectory of the rocket and the position of the rocket, actual position, our altitude. We're flying at the moment 502 kilometers high, which I believe is pretty well our correct altitude for separation, and we are flying at a speed of just under 8 kilometers per second, waiting to go into New Norcia. Tracking station's footprint, as you mentioned there, for some lovely images here of our satellites
Acquisition de la télémesure par la station de New Norcia.
To the upper stage. And he's just confirmed there, the range operations manager, that we have picked up the signal at the tracking station in New Norcia, which is now tracking the second switching on of the AVUM Plus upper stage.
Deuxième allumage AVUM.
Confirmed by the range operations manager.
Good news. It's an important step. Yeah.
It is an important step, isn't it? And why are we switching it on now?
So right now we have reached, let's say, the altitude of the injection for CO3D, and we want to exactly have the orbital parameters fit for the mission of CO3D. So we are boosting a little bit for about
La propulsion est nominale, la trajectoire est nominale.
So a little bit more than 1 minute, and we are just adjusting exactly the orbit of injection for the 4 satellites. So you will see the burn, then some maneuvers to orientate in the right direction the satellites.
And we're doing something called closed-loop guidance. What's that?
Yes, true. It's an important feature of the AVUM stage, which is able to correct the trajectory and the path on where it's on, because you may have some dispersion or some deviation for whatever reasons. Of course, it's not a perfectly guided thing. So the AVUM is able to go back on the right track and to very precisely inject on the right spot the satellites that once we have reached their injection time.
So it's very clever. It corrects its trajectory. And we have confirmation there that these AVUM Plus upper stage has now switched its engine off again. And that's very important, isn't it? Because we're really getting close now to the next very,
Début de la
very
manœuvre
big
d'orientation au profit de CO3D.
Which is the separation of our satellites, and he's just told us that we're orientating the
Yes, we are
stage.
doing some maneuvers to make sure that we will separate the satellites in the right direction and the right, let's say, velocity vector, we say. So we are separating for this mission in orbital velocity directions.
So why are we pointing downwards and twisting?
Now twisting because we want to orientate exactly the satellites in the right directions once again, because they will be, as we said before, working by pairs. So we want to make sure that the right two of each pair is separated in the right direction. So we are once again adjusting that.
And when we release them, they're going to be pushed away, aren't they, with a set of springs?
Yes, and there's a specific device developed from the Clessidra Plus dispenser, which is now holding them very tight. It's kind of a spider, you know, with 4 legs only, but a spider that is holding the 4 satellites very strongly, and it will be smoothly released once commanded.
That's how it looks. 2 satellites being released first, and the second 2 5
Séparation des satellites CO3D 1 et 3.
And we have confirmation there that the 4
Séparation CO3D 2 et 4.
The 4 satellites have been separated from the mothership.
Début du premier boost d'éloignement.
And there they are, great images there of the satellites moving away from the Clessidra Plus attachment device, which, as you say, has been very specially designed for this mission. So huge congratulations to everybody, and massive congratulations to the Airbus teams, to the CNES teams, to everybody, to all the contractors who have been involved in making this mission a reality. And also now the teams, of course, at the operational centre in Toulouse will be taking charge now of their satellites, and obviously laser focus for them too. So we still have microcarb attached, and I'm very glad to have with me Patrice Garous, who is from the European Space Agency, because microcarb is a very important satellite for Europe. And Patrice is in the In-Orbit Demonstration and Validation Program Manager at the European Space Agency. Patrice, what is that? What does that mean exactly?
Yeah, first, thank you very much for inviting me tonight. So I wish you and our audience is appreciating this very smooth ride offered by your Vega-C rocket tonight. And yeah, so the in-orbit demonstration, in-orbit validation program has been initialized by the European Commission and is fully delegated to ESA for implementation, the European Space Agency, as you mentioned. And this program is offering in-orbit demonstrations, so flight opportunities for innovative payloads in a form of either an equipment, a new service, or a ready-to-fly satellite in order to perform their in-orbit demonstration.
So it's great because it means that people get the chance to actually demonstrate, test, and get their ideas into space, which is obviously so important.
Indeed.
And I mean, Microcarb is a really important mission. I mean, it's an important mission for all of us because it's measuring carbon dioxide. But why is it so important for Europe?
Yeah, Microcarb is really an important mission for Europe because, as you mentioned, it is going to accurately measure the carbon dioxide concentration in the atmosphere of the Earth, globally, all around the Earth. And the data provided by the instrument will be used by the scientific community in order to further refine their models, in order to have a better accuracy on the forecast for the evolution of the Earth's climate. So this is extremely important for Europe, European citizens.
Yeah. I can see that. I can see that. And it's the first one, isn't it, to do that?
Yeah.
And how does Europe actually contribute to the Microcarb mission then?
So Europe contributed to the Microcarb mission by because it's a very good cooperation example in Europe, since it is funded by several organizations, CNES, the UK Space Agency, and European Commission via the European Space Agency, which is funding 2 key elements for the Microcarb mission. One is a product data processing unit, which is in the ground segment, and that will refine the data, the raw data downloaded by the instrument to the ground into elaborated, refined data with accurate CO2 measurement that will be used by the scientific community to, as I mentioned, refine their model.
And are there any other opportunities coming up for other new ideas, like microcarb and innovative experiments, for example?
Yes, indeed, because this in-orbit demonstration, in-orbit validation program is up and running at the moment. And we will be selecting through the European Commission call for expression of interest new innovative payload until March 2027. So we have a cut-off date where we select payload every 6 months. And then we will have flight opportunities up to 2029, where we will offer European actors, being prime contractors, SMEs, laboratories, universities, that have an innovative payload in the form of an experiment, a new service, or a complete ready-to-fly satellite, to offer them an opportunity to access to space to demonstrate their technology.
Right, so you heard it here first. If you've got an idea,
yeah.
he's your man.
Exactly. So one of the key messages tonight is that if you have an innovative payload to demonstrate in orbit, please apply to this open call of European Commission. And this call and this IOD-IOV program is made for you.
La propulsion est nominale.
Well, thank you very much indeed,
Thank
Patrice.
you to you. Yeah.
Well, yes, and congratulations to the CO3D teams. And now we're looking forward to Microcarb getting to its orbit so that it can release
calme, la trajectoire est
That's
nominale.
going to be in roughly about 40 minutes. Patrice Kerhus, thank you very much indeed for joining us.
Thank you.
So we have now switched our engine on for the third boost, and the range operations manager is telling us that all is going well in space and that the piloting is going well.
La trajectoire est nominale.
And our trajectory is nominal or normal. So Loïc is back with us. Loïc, why have we switched the engine on now?
So right now we will want to raise the orbit towards the microcarb injection orbit, so about 150 kilometers above the CO3D orbit. So that's what we are doing this.
So we've now switched off the upper stage engine. Yeah. Sorry to interrupt you. So if we look on the screen there on the right-hand side, you can see that we're really climbing again. So we've gone through a phase of sort of plateauing out slightly, and